Hello everyone. In this video, I will be going over our final project of excellence, our sumo bot, WALLE. Specifically, I'll be discussing how we apply the engineering design process and how it led to our success throughout the project. Step 1. Define the problem. The problem we were given was the following. Design a VEX robot that can operate both autonomously and manually with the goal of pushing opposing robots into the wall while avoiding contact with the wall itself. The second step to solving this problem was generating concepts and brainstorming. First, we each created individual concept sketches of the robot, including notes about its intended design and purpose. Next, we developed a decision matrix to compare our ideas and select the most effective design to move forward with. We decided to use Skylar's design, which included a lifting arm mechanism. With our newly chosen design, we were able to move forward with developing the solution. After creating more detailed sketches, we moved on to designing the robot assembly in Inventor, starting with the chassis and drivetrain, and later developing the lift arm mechanism. Next, we began coding. For the autonomous portion of the code, we programmed the robot to trace the arena's border while avoiding other bots. In manual mode, the robot was controlled using the joysticks, and we added functionality to raise and lower the lift platform using specific buttons on the controller. With the design finalized, we moved on to constructing the robot and eventually began testing its performance. First, we built the chassis of the robot, including the drivetrain, which featured four 2.75-inch wheels, each side powered by a single motor connected through a 7-gear drivetrain. Next, we constructed the lift mechanism, which include lift arms powered by one motor on each side. Small gears were connected to larger gears to create an optimal gear ratio, allowing the robot to lift heavier loads. The goal of this design was to slide the front plate under opposing bots and use the lift arms to either flip them over or stop their movement. With construction complete, we were ready to begin testing our robot. We tested the robot by lifting heavy objects such as a chair, and by conducting mock battles against other groups' robots. During testing, we found that our design was mostly effective, but required a few updates and improvements. With that information, we were able to move on to the evaluation of the solution. After testing, we identified the need to make minor code adjustments, reinforce the lift platform for greater stability, and modify the drivetrain's gear setup to prevent it from rubbing against the ground. With our design complete, it was finally time to present our solution at POE night. Throughout the night, we presented our solution to guests, explaining our design and the process we followed to achieve it. We also competed against other robots throughout the night. Our lift plate proved effective, successfully flipping two opposing robots. Thanks to our drivetrain, we were able to maneuver precisely and position ourselves strategically for each lift. During the autonomous portion of the battle, our robot traced the edge of the arena, avoiding other bots. And when it switched to manual mode, we strategically positioned ourselves underneath other bots with the goal of flipping them over. Overall, this project challenged us to apply the engineering design process from start to finish. Through problem solving, collaboration, and hands-on testing, we created a functional and competitive sumo robot. The experience not only helped us improve our technical skills, but also taught us the importance of planning and design thinking. I hope you enjoyed the video. Thanks for watching.